Good day, everyone. I am James Andrew Palacio, and together with me is Mr. Ryan Hojas. Together, we will explain to you the concept of proportional reasoning. For this lesson, you must be able to demonstrate proficiency in understanding and applying key concepts related to ratios, proportional reasoning, and comparing and scaling. Next is to identify different types of ratios, such as proportions, and use them to make comparisons between quantities. Lastly, you must develop the skills necessary to apply proportional reasoning to solve problems involving ratios and proportions effectively. So, are you ready? Let's begin. So, first, we will have a vocab session, which is ratio. What is ratio? According to this, ratio is a comparison of two quantities. The ratio of A to B can also be expressed as A column B or A over B. Next is proportion. Proportion is an equality of two ratios. We write proportions to help us establish equivalent ratios and solve for unknown quantities. There are three main types of ratios that we will discuss today, which is part-to-part ratio, part-to-whole ratio, and equivalent ratio. The two common types of ratios that we'll see are part-to-part and part-to-whole. For example, when we make calamansi juice, the ratio of calamansi to sugar is part-to-part ratio, as it compares the amount of two ingredients. The ratio of calamansi to calamansi juice is part-to-whole ratio, as it compares the amount of one ingredient to the sum of all ingredients. So, how do we write ratios? This is the process on how to write ratios. The first is to determine whether the ratio is part-to-part or part-to-whole. The next is to calculate the parts and the whole if needed. Next, or number three, is to plug the values into the ratio. And number four is to simplify the ratio if needed. Integer, integer to integer ratios are preferred. For example, here is a scenario. Consider a high school basketball team with 25 players. Out of these, 15 players are from grade 9 and 10, lower level students, while 10 players are from grades 11 and 12, or seniors. What is the ratio of lower level students to the total number of students in the basketball team? The answer is that the ratio is that lower level students to the ratio of number of students in the basketball team is a part to whole ratio. There are 15 members on the basketball team which are lower level students or lower level students. The ratio of lower level students to the total number of players on the team is 15 to 20, which can also be written as 15 column 25 or 15 over 25. This can also be reduced by finding its GCF, which is 5, and crashing them out. So you will be left with 3 over 5 because those two have nothing in common. So this means that the ratio of lower level students to the total number of students on the basketball team is 3 is to 5. This is equivalent to 3 over 5 of the students on the basketball team are lower level students, and 3 fifth or 3 in 5 students of the basketball team are lower level students. So next, we'll have another vocabulary session. Equivalent ratios. These are ratios that have the same value. Given a ratio, we can generate equivalent ratios by multiplying both parts of the ratio by the same value. For example, 2 to 3 is equivalent to 4 is to 6 or 6 is to 9, and so on, much like how 2 over 3, 4 over 6, and 6 over 9 are equivalent fractions. This can be seen as shown above. 4 over 6 is equivalent to 2 over 3. This is because the GCF of 4 and 6 is 2. So we crush them out. So we'll be left by 2 third. Next, we have a 6 over 9 is equal to 2 third. which is an equivalent ratio to the 4 over 6. This is because the GCF of 6 and 9 is 3. So you will be left with 2 thirds. So next is the lesson about how do we use proportions. This is the process on how to write or use proportions. First is to write an equation using equivalent ratios. Next is to plug in the known values and use a variable to represent the unknown quantity. Third, if the numeric part of the ratio is a multiple of the corresponding part of the other ratio, we can calculate the unknown quantity by multiplying the other part of the given ratio by the same number. Number 4, if the relationship between the two ratios is not obvious, solve for the unknown quantity by isolating the variable and representing it. An example would be a recipe calls for 3 cups of flour to make 24 cookies or 3 is to 24 ratio. If you want to make 36 cookies, how many cups of flour will you need? The solution will be let x represent the number of cups of flour needed to make 36 cookies. We can then set up a proportion based on the given information. This will be 3 cups of flour over 24 cookies is equivalent to x cups of flour over 36 cookies. To find x, we can cross multiply. So you will be left with 3 times 36 is equal to 24 times x. Next will be 108 is equal to 24x. 20 or next will or the next step would be dividing 24 over 24, so we will be left with x. So according to law of equivalency, you must also divide 108 over 24. So 108 over 24 is equal to x. 108 over 24 or 108 divided by 24 is equal to 4.5 is equal to x. So you will need 4.5 cups of flour to make 36 cookies. I hope you understood that. So you will be proceeding to Mr. Ryan Hoa's discussion of comparing and scaling.
Hello, young ones. Today we'll be discussing or teaching you some basics of comparing and scaling. So, comparing a proportional reasoning involves assessing the relationship between two quantities to determine if they are in a or proportional relationship, often by testing for equivalent ratios or graphing on a coordinate plane. On the other hand, scaling in a proportional reasoning refers to adjusting a ratio, rate, percent, or fraction to create an equivalent ratio or rate. But in this portion, we will tackling the basics of comparing and scaling. Here we have the problem of or looking for the ratio of the on this shown table. So in this table shows that the medal count of four classrooms at the 2015 Jackson Middle School field day, where he's looking for the ratio of Mrs. Smith's gold to Miss Davidson's medals was. So in this shown table we have Mrs. Davidson's Mrs. Smith's gold was 28 and Mrs. Davidson had a 14. So we have the ratio of 28 to 14. Or this can be reduced to 2 to 1. Another would be Mrs. Hernandez had about times as many total medals as Mr. Chow. So in this table, Mrs. Hernandez had 21, while Mr. Chow had 62 medals. Therefore, we have 51 over 62. And on this another example, is looking for the percent of Mrs. Hernandez's total medals that were gold. So Mrs. Hernandez had 51. No, has 31 gold medals over 51. And then we have the solution of dividing it from 13 over 51. So you just get your calculator and then divide it, just divide it from 13 over 51. And here we have the solution of 25%. So in this another example would be comparing the 48 pretzels in a 16-ounce bag of chocolate-covered pretzels. Here is the solution where we are going to write in solver proportion that we can use to find the number of chocolate-covered pretzels in an 8-ounce bag. In an 8-ounce bag. So we we will going to use the cross method where 48 pretzels and you have over 16-ounce bag of chocolate-covered pretzels and then the unknown number and the number of 8 ounces bag over the unknown number. So we have just to times 48 times 8, we have 384 and then divide it by 16 and here we have the result of 24. Therefore, the unknown number would be 24 pretzels. So let us proceed with the scaling. So you must be wondering what the scaling mean in math. Well, scaling is a procedure through which we draw an object that is proportional to the actual size of the object. Scaling in geometry means that we are either enlarging or shrinking figures so that they retain their shape. When we scale figures, they are known as similar figures. So let's take for example these objects or these figures where larger figures shrinking, turning into small ones. And this is another example when this German Shepherd in real life, when we draw things from the real world or on paper, we use a scale to make sure our drawings are the right size. For example, a scale of 1 to 10 means that 1 unit in the drawings stands for 10 units in real life. So this helps us show objects accurately on paper by making them bigger or smaller based on this ratio. Here, that the German Shepherd is of height of 40 inches in the real world and is represented as 4 inches in the drawing. It shows that a scale of 1 to 10 has been used. So we can see the difference between the real object now compared to we draw one. So we have come up with a scale factor and scale types. So we have the scale factor. In simpler terms, a scale is like a ratio used to show the relationship between the size of a model or drawing the actual size of an object. On the other hand, a scale factor is a number that tells you how much bigger or smaller parts of an object are when you make it bigger or smaller parts of an object are when make it larger or smaller. These concepts are commonly used in blueprints for building constructions to, to accurately represent objects in drawings. So we here are the key points of scaling factor. A scale factor can be determined by comparing the dimension of the original figure with those of the enlarged or reduced figures. Scale is the ratio of the dimensions of the new shape to those of the original shape, where scale factor is calculated by dividing the dimensions of the new shape by the dimension of the original shape. So this is another example, similar in my previous example, right? Where using a scale factor and scale in a blueprint context could be a table. If a table is meant to be 60 inches long in real life and is represented as 5 inches in the blueprint, the scale would be 5 to 60 or 1 to 12 with a scale factor of 1 over 12. This means that every unit on the blueprint represents 12 units in real life, or in reality, helping accurately depict objects in the drawings. So we have lastly the types of scaling. We start with the scale up. When we want to make a small figure bigger, we scale it up. This means increasing the size of the figure. To calculate the scale factor for scaling up, we use the formula scale factor dimensions of the new shape divided by dimension of the original shape. The scale up factor is found by dividing the dimension of the original figure by the dimension of the smaller figure. Scaling up is often chosen when dealing with very small objects. For example, when we, when we need to draw a butterfly on a paper to study its details, we would scale it up to make it easier to see. And for example, if we need to draw a small butterfly on paper to study its details, we would just scale it up to make it easier to see and work with it. So here in our example about this frog, where the key points of larger figure dimensions divided by smaller figure dimensions, where 15 over, ah, sorry, I mean 15 divided by 9, resulting of 1.6, wherein this scale up factor would be it is always greater than 1. So 1.6 is greater than 1, and So find the scalar factor that is greater than 1. So with the scale down, or its scale factor, dimensions of the new shape, dimensions of the original shape. So its scale down factor, smaller figure dimensions divided by larger figure dimensions. So in this shown example, we'll further elaborate on the next slide. Now, let's consider a living room as another example. Suppose you have to design a living room of size 20 at 140 inches by 180 inches. To draw its blueprint at a scaled down size, we will reduce it to 20 inches by 15 inches. This scaled down blueprint will help in planning the layout of furniture such as sofas, coffee tables, and entertainment units within the living room space effectively. So we have the smallest figure dimensions divided by largest figure dimensions. So our smallest figure dimensions would be 15 inches divided by our largest figure dimensions, which is the 240 inches, which result to 0.625 or less than 1. With the scale down, it is always less than 1. So that's all for today, guys. I hope you learned something with me about comparing and scaling. So that's it, guys. Hope you learned about proportional reasoning or one of its. Hope you learned with me, guys, about proportional reasoning, comparing and scaling.
So after you have seen our video presentation, let us proceed to your quiz. In here, we will have a QR code that you can scan or a link that you can go through. This will lead you to a pair deck quiz that will be open for your answers. In here, we will test if you understood the proportional reasoning or not. So I hope you enjoyed our lesson today, and may we see each other again next time. Peace.